Hi, and welcome to the OSVR presentation here on Unite 2015 in Amsterdam. So our topic today is future-proven virtual reality games and applications in general, and how to create them with open source virtual reality. A bit about me, I'm Andre from Razer. Razer is one of the founding members of OSVR. I'm a senior PR specialist, so mainly working in the field of marketing for Razer, though I'm a tech enthusiast and OSVR product evangelist for Europe. I'm working in the video game industry for about 9 years, mostly for publishers and development studios, and bringing various games from various engines from Korea to Europe. Yeah, so much about me. So the scope of this talk, first of all, we want to give you a bird's eye perspective on the platform itself, what it can do for you, and what it basically does. Then we go down a bit more into the technical details to provide you an idea of how and what we do and how it actually benefits you as a developer. And then I will also speak about our Hacker development kit, which is basically an affordable head-mounted display if you want to start virtual reality development. So let's jump in. First of all, our vision. Open source virtual reality is not a company. It's a consortium of companies working together to build a standard in input and output of virtual reality content. That means we are hardware agnostic, we're platform agnostic, we're also software agnostic, so you can use OSVR with virtually everything that's integrated to the platform. In a nutshell, that means that we are an open source platform licensed under Apache 2.0. Which allows you to use it in non-commercial and commercial project alike. We support open source hardware and software. So far we are available on a couple of platforms, Linux, Windows, and Android, with all the major other platforms like macOS, iOS, and Windows Phone coming later on. We aim to provide a reliable standard for developers in virtual reality. We already see now on various platforms hardware fragmentation coming up in input devices, in output devices. Like there are already a lot of virtual reality HMDs on the market. Same goes for input devices. And we want to counter-attack this and provide a good standard for you to use so you don't have to take care what your end user is actually going to use to play your game or use your application. And the big factor that actually enables us to do that is that we are supported by industry leaders and startups alike. So speaking about industry leaders, we have now 145 partners with a couple of big names on board already, like Ubisoft, like Sensix, even other engines like Unreal, so it's not like a Unity thing. It's available everywhere. And with that, we're actually enabling ourselves to get AAA titles on board. So we actually can reach a traction where users are getting like into a commercial factor on wanting virtual reality at home. That's a great thing also for indie studios, because like as soon as the hardware is available at the end user, you can really start to create your business on virtual reality, which is at this point in time barely possible since it's hard to monetize at all. As a partner snapshot, just as announced, we're 145 partners. I'm not going to be able to name them all. You can see them all on our websites, but we have quite a lot with a couple of cool big names. Coming down to why to use OSVR. So what it does for you. So OSVR is basically an abstraction layer for input and output. So instead of tying your game and your software into one API to just use one input device or one output device, you can actually use it to virtually create everything and get every input mapped to your player. Therefore, it reduces your risk on like failing hardware platforms. If you rely on a hardware platform that then doesn't get sold to the consumers or is not successful enough, you would lose potential customers out there, and with that you can simply reduce it. I'm now going a bit more into the technical details on how we actually do this and how you can actually integrate this. So to do this, you actually simply integrate the API of the OSVR, which then runs a core server on the end user's computer, which provides a path tree. So the first thing that you actually do is to abstract names. For example, here we have com OSVR multi-server / Razer Hydra 0 / tracker / 0, which simply becomes to a /me / hands / left or /right. So with that, you don't have to name anything literal. That means, for example, if you want to include hand tracking in general or sensors from hands, it doesn't have to be a Razer Hydra, it can also be a Leap Motion. Since, in a sense, they're providing the same sensoric data back to us. So with /me / hands / left, you're already addressing a lot of devices that are now on the market or become available on the market. It also applies filters and SmoothNet, if you like. For example, high-resolution hardware like the Razer Hydra, for example, can jitter a bit, and that's like not a nice experience for the user. And like even there, we get you covered, and it provides you the ability to simply smoothen the input, so it's less apparent for the user that it's actually like more sensoric data than you're actually using. This helps you a lot in development. As already said, with not addressing the hardware literal, but on an alias, you can become hardware agnostic. So it provides you security in development. You don't have to go back. You don't have to rewrite things that you already implemented just because something's failing or not working as you expected it. But you can simply continue. And it also makes your game and applications future-proven. That's actually a big factor. Like if you start developing a lot of content for virtual reality games now, you're probably going to be to publish in 1 or 2 years down the road. And I at least can't foresee which kind of hardware will be available then on the market. But as long as it's integrated with OSVR, it will anyway work down the path. Also, we have a lot of standards for human interaction, which can easily address. For example, if you work at your office with Oculus DK2, you can simply map it as an output device on /me /head, and then already support 11 other HMDs, including the OSVR HackerDev kit, and or upcoming things like Brianna's Totem. So it's already everything working out of the box, and it just removes a lot of pressure from you to address this hardware properly, since we already took care about it. Especially the developers themselves took native support into OSVR. And last but not least, hopefully it won't mess up your code and just look a bit nicer. Going down a bit more on the hardware, since this is also a talk for starters, we have our own head-mounted display available. It's now shipping to partners. It's called the OSVR HackerDev Kit, HTK for short. It's very accessible, so it's a fully modular head-mounted display. It comes pretty affordable, so for $199. And it has a lot of amazing and cool technique inside that is reliable to you. So we have a 5.5-inch full HD OLED screen with also sensor modules available. So head tracking is already in that. We have a fully modular optical system, so you can set the lenses to your personal view, which is great for people like me wearing glasses, for example. You can simply work out, so you can still see all the contents displayed on the OLED screen sharp, without any hassle or without exchanging any lenses. It's also a dual lens system, which then frees you of the annoying task of working against chromatic aberration, since the lenses basically take care of this on a mechanical view, which then saves you resources in rolling out your software. It's available now, basically, for a pretty affordable price, so it's $199 for the version 1.1, which comes with the OLED screen. We just announced the version 1.2 at E3, basically a week ago, which comes with positional tracking via infrared camera. And as said, it's a fully modular system. So you can also upgrade it at home. So just in case you already bought one and you now want to have positional tracking as well, it's basically just buying a kit and taking a screwdriver at home, placing it in, and that's how it works. So it's basically like build up like a modular PC. We also have other kits available, for example, like if you want to go into virtual reality development on mobile platforms, as we, for example, already support Android, you can simply exchange the faceplate and plug in a module that allows you to push in your mobile phone. And with other things coming down the road, that's also a great thing for the future. That's pretty much the information I have now. I'm open for questions. If you have anything that you want to discuss later with me, my contact information are there as well. Also, we are fully working with Unity already, so there's a prefab available, which can be just obtained via GitHub, like all the other code. You can see the roadmap. It's, we are really taking care about being transparent in the way we're developing the platform itself. So we're using Waffle.io for that. You can see which features are requested, which features are currently worked on, and even an estimate when they will come to you to use. So any questions? Okay, so thanks a lot for your time. I hope it was interesting to you, and let me know if you have any questions later on.